In today's video, we're going to take a look at 6 awesome CLI tools for benchmarking and stress testing your Mac or Linux computer. On Mac, you can install all of these tools using Homebrew, and I have a video about that linked above. And on Linux, you'll find all packages in the package manager for your distro. Let's dive straight in. First up, we have Speedtest CLI, which is a tool for testing the speed of your internet connection. From the terminal, run speedtest-CLI, and then after 15 or 20 seconds, you'll get a report for both your upload and your download speed. By default, Speedtest CLI uses multiple connections in an attempt to max out the speeds you get in your test. If you're more interested in the speed you'll see for file uploads or for file downloads, then you can use the -- single flag to run a test with just one connection. And if you're looking at the results of your speed test and they seem a little bit low, you might want to try from a machine connected to Ethernet, not Wi-Fi. If I run my test again from a machine with a wired connection, the measured speeds are much higher and are much closer to what my ISP tells me I should get. Our next tool is 7-Zip, which, yes, is a file compression tool, but it also has a great set of CPU benchmarks built in. Running the B command of 7-Zip runs a basic CPU benchmark, and the results are quite interesting. First up, 7-Zip tells you how many CPU cores it found along with their frequencies. Now, I use this to sanity check my benchmarks just to make sure that there's no weird frequency scaling, to make sure that my machine hasn't dropped off wired power and is running on battery, that kind of thing. Each test has 4 interesting measurements: speed, usage, rating, and normalized rating. Speed is a measure of how fast data can be compressed or decompressed, and higher is better here. Usage might be a little confusing at first. How can you have a usage that's over 100%? Well, maximum usage is actually 100% per hardware thread. So on my 10-core machine, or 10 hardware thread machine, has a max usage of 1000%. Rating is measured in MIPS, or million instructions per second, and again, higher is better. And then finally, we have normalized rating, which is the MIPS rating divided by the usage. When you're comparing results across 2 machines, the speed is ultimately what matters. Here I have a comparison of my Ryzen 5950X, which has 32 hardware threads, with my M1 MacBook Pro, which has 10. The Ryzen is about 1.8 times faster and delivers about 1.8 times as many MIPS, but the normalized rating of the M1 is twice that of the Ryzen. Essentially, each hardware thread on the M1 delivers twice the MIPS of the Ryzen processor on this benchmark. So this basic test only tests the LZMA compression algorithm, and for a more comprehensive test, you can run the B command with the -mm = flag to try out many more algorithms and get a much more thorough CPU benchmark for your machine. Moving on from CPU benchmarking to disk I/O benchmarking, we have iozone. iozone is a great way to quickly benchmark your storage devices, so things like SSDs, SD cards, compact flash, that kind of thing. For a comprehensive suite of tests, simply run iozone with the A flag, A for automatic, and also set -I for direct I/O. This will bypass the buffer cache, so it's a much more accurate measure of the disk's performance, and when you're running multiple tests, it reduces the interference between those tests. In automatic mode, iozone runs a ton of different tests, and reading the results can be quite confusing, so I like to use the -B flag to write the results to an Excel spreadsheet that's then much easier to read. Within this Excel spreadsheet, the results are grouped by scenario like writing, rewriting, reading, and so on. And for each scenario, the first column shows the size of the file that was processed, and the first row shows the record size, which is essentially how large are the individual reads or writes in each test. And both of these values are measured in kilobytes. Then each test result is shown in the appropriate cell, measured in kilobytes per second. So in these results, writing a 124 kilobyte file 16 kilobytes at a time happened at around about 218,000 kilobytes per second. I like to run iozone on all storage devices I get, and I'll usually store the results so that later on I can rerun the test to see if a particular device is degrading. I also like to use iozone as a way for selecting SD cards for my camera to make sure that I'm picking the SD card with the best performance. Next up, we have iPerf3, which is a great tool for testing the speed of your local network. Now, to run a test with iPerf3, you'll need 2 machines, one to act as a server and one to act as a client. Both machines must have iPerf3 installed. On the server, run iPerf3-S, -S for server, And then on the client, run iperf3-c for client, followed by the hostname or IP address of the server machine. The default test will emit results every second and it runs for about 10 seconds. At the end of the test, you'll get a summary showing you how fast your connection is. If you can, you should connect to a server that is wired into the network. And it's also worth testing a wired client as well, so you can get a sense of what your network is really capable of. And then when you're testing Wi-Fi, you'll want to test from different rooms in your house, and this can help you find areas where you might need to improve your Wi-Fi with a repeater. Let's now turn our attention to memory benchmarking, and for that we're going to use sysbench. Sysbench is a very flexible, highly scriptable benchmarking tool that you can use to create all kinds of different benchmarks. I think it's the case that sysbench was originally created for database benchmarking, but I like to use it for its built-in benchmark scripts and specifically for the memory benchmark, which we run with sysbench memory run. The default test runs for 10 seconds before writing out the results to the terminal, and you'll want to pay most attention to the operations and transfer statistics blocks. In both cases, higher values are better, and you can definitely use these values to compare across machines and across parts. I always run this test before and after replacing memory chips to make sure that I'm at least seeing the same performance and that I haven't got a dud part. Of course, a short test like this isn't enough to really validate part quality. For that, we need a stress test, and that takes me nicely onto the final tool for today, which is StressNG. Using StressNG, you can drive different parts of your machine as hard as they will go, looking for failure cases or just as a way to see what your machine is capable of. StressNG has a lot of different stressors for stressing different aspects of your machine, and you can see the full list using StressNG --stressors. I can't go through all of these in this video, but let me know if you'd like a deep dive on stress testing. Today though, let me show you the stress test that I like to use whenever I build a new machine or whenever I upgrade a part in a machine. I run StressNG --CPU 0 to run the CPU stressor on all cores, and that's what the 0 means. Then I run --CPU-load equals 50 for 50% CPU usage. Then --IO1 for a single IO stressor, and --malloc1 for a single memory allocation stressor. And then finally, I set -t to 10 to run the stressors for 10 seconds. And I'll usually build up from 50% CPU usage to close to 100, and from 10 seconds up to maybe 5 or 10 minutes, once I'm sure that there's nothing fundamentally wrong with the machine, and I really want to just test things out and see how far I can push it. So there we go, 6 great command line tools for testing the performance of your machines. If you like this video, I have 2 other videos so far on command line tools, and I'll link them both in the description below and to a playlist where all my Linux content is contained. Hope you found this video useful, I hope you found it entertaining. If so, please hit like, please hit subscribe, maybe hit the bell as well, so you don't miss out on any future content. Thanks so much for watching, and I will see you in the next video.